I'm going to talk to you today about Spearman's rank correlation coefficient. So Spearman's rank correlation coefficient then, we'll be learning how to use it, what it's used for, think about what it's used for, and how to interpret it, and then you can have a go at doing some Spearman's rank correlation coefficient calculations for yourself. So Spearman's rank then is a statistical test that's used to assess the strength of a relationship or correlation between two variables. And they can confirm whether there is a correlation or whether there's no correlation. Sometimes correlation, sometimes there isn't. We've got the equation for Spearman's rank just here. I'm going to break this down for you into steps so you can figure out how to use this equation. So you would get given this equation in an exam situation, but you do need to know how to actually use this equation and what order in which to do things in. So Spearman's rank then always gives an answer between -1 and +1. So -1 would be a perfect negative correlation. 0 would be no correlation at all. And +1 would be a perfect positive correlation. So 0, no correlation, -1, negative correlation, +1 is a positive correlation. So where they have perfect correlation. And we'll have a look at some graphs to illustrate that in just a moment. So if we had a Spearman's rank of 0.8, that's close to +1. So that means that there is a correlation, a positive correlation between those two variables. And if one of those variables increases, then the other one will also increase. If it was -0.8, then again it's linked, but you would have a negative correlation there. So as one increases, the other one decreases. And if it's no correlation, then you have a value that's pretty close to 0. So we've got some graphs here just to illustrate that point. You can see here with a Spearman's rank of 1, so the R there represents the Spearman's rank correlation coefficient there of 1, you've got a perfect positive correlation. Here in this graph, you've got a perfect negative correlation where the R value is -1, and then here we've got an R value, a Spearman's rank value of 0, and you can see that there is no correlation whatsoever. So you can use graphs to see if there's a relationship. They're quite good, but the reason why we use stats is so that we have extra evidence to substantiate any conclusions that we are going to be making. So they will use that Spearman's rank, then scientists will use the Spearman's rank to substantiate the claim, to say how strong that particular relationship is. So they can be a lot more confident with the conclusions that they've drawn. So the example that we're going to be looking at is the effect of light intensity and plant cover in an area. So students measured light intensity. You can get a special little light meter that you can use to measure light intensity. And they looked at plant cover at 6 different sites. And they wanted to see whether higher light intensity meant that there was a higher plant cover. So I suppose that's their theory then. Their theory is that the higher the light intensity, the higher the percentage plant cover. And here are the results. So you can see we've got the light intensity just here. We've got the percentage plant cover just there. So we're going to be using then the Spearman's rank to have a look at that result and make some sense of it. So step for Spearman's rank, then the first thing that we need to do is to state the null hypothesis. So we'll do a null hypothesis for this. Then we need to rank each of the data. And we need to calculate the difference between those ranks. So this figure D that we've got here represents the difference between those ranks. which is rank 1 minus rank 2. Then you square that difference, add them all together. So that gets you to this point here, the sum of d squared there. Then you multiply that by 6. And then you divide the answer to step 6. So divide that then by n times n squared minus 1. So n is the number of paired values that you've got there, number of pairs of values. And then you do 1 minus the answer to step number 7. So we'll do this step by step now. Starting off with step 1 then. So step 1 then, no relationship, this is the null hypothesis, that there is no relationship between light intensity and that percentage plant cover. So the first thing that we need to do then is to rank each set of data. So here I've ranked from the largest to the smallest. So you can see 700 is number 1, 650 number 2, and so on. And then I've done the same with the other set of data. So those have been ranked as well. So that's step the first step of doing this equation there. We've got the ranking of each set of data, but step 2 in this particular step-by-step that we're doing. So we have the null hypothesis, okay. Then you need to calculate the difference between those ranks. So we do rank 1 minus rank 2, which you've got here minus 1, 6 minus 1 is 5, 1, 4, and 0. And then we need to square that. So 1 squared is 1, 5 squared is 25, 1, 16, and 0. And so at this point here, the d squared. And then you need to add all of those together. So this is the sum of. If you look at the standard deviation video, I go through what some of these different symbols mean as well. So this means sum of. So I'm going to add all of those together. So 1 plus 1 plus 25 plus 1 plus 16 gives you 44. And then multiply it by 6. So you can see actually I've done the next steps in here and multiplied it by 6 there. So 6 times 44 gives you 264. 264 then divided by n. So the n, because they did 6 sites in this case, the n is 6. And then that's 6 times n squared minus 1. So 6 squared is 36. Minus 1 is 35, which one times it by 35 here. So if you do the 264 divided by 6 times 35, that gives you 1.257. Now the next bit is the bit that people always forget to do, which is the 1 minus this figure here. Okay, so 1 minus 1.257 gives you minus 0.257. So our Spearmans rank value then for this is minus 0.25714, I suppose, but we would round it to, I think 3 decimal places would be appropriate for this one. What does this mean? That's what we're going to think about next. What does it mean? Well, you can see that it's actually low. So using this idea here, it's close to 0. So that tells us that there's no or little correlation. But what we also do is compare it to a table of critical values. So the critical value for this data here is 0.89 for us to say whether there is a correlation or not. Again, we use this MRSA that we've talked about before. So if our calculated R value is more than the critical value, then we reject the null hypothesis. And if it's smaller, then we accept the null hypothesis. So you can we can compare then on the calculated Spearmans rank. So our calculated Spearmans rank then is 0.26. That's much smaller than the critical value of 0.89 at the 5% significant levels. So we're going to accept the null hypothesis and confirm that there is no significant correlation between light intensity and plant cover. And if we do a graph of that, you can actually see quite clearly that there is no relationship. So we've got two pieces of evidence now. We've got the graph here, and you can see I've just done an XY scatter graph. It wouldn't be appropriate to put a line of best fit in this data because there is no correlation between those two. Okay, and that's confirmed by our R value that we've got here for our Spearmans rank. Good. Any questions? Do email me or speak to me on Teams and have a go at doing some of these for yourself.